Hello everyone, welcome to Handmade Hero, show where we code a complete game, live on stream. Before we get started today, I wanted to point out the fact that tickets are now on sale for Handmade Seattle. Don't ask me why, there's nothing. Let me do that, there we go. At handmade-seattle.com. This is not our conference. I don't really run any conferences anymore. But it's a conference run by Abner, who you may know from, he's the person who originally organized the Handmade Network website. And obviously it's taking place in Seattle, so if that's a place that you can either get to or live in, tickets just went on sale. They're $40 for a limited time. And the tickets button, looks like you just click on it and put it in here if you want to get tickets. Obviously, there's a bunch of information on here about what the conference has at it. Abner's been adding stuff, so go take a look, see if that's something you're interested in, and save yourself some money if you want to go, because the ticket prices, I guess, will go up after the early bird discount expires. All right. Today we are just going to do a little bit of a... Okay, wait, I have to correct something. It says, I'm surprised at Case like Chrono Trigger. I haven't played Chrono Trigger. Someone has to fix this. I haven't played it. I need to play it. It's a game historically that I should be familiar with, but I haven't played Chrono Trigger. All right, sorry. The chat's still talking about Chrono Trigger from the pre-stream. I didn't even bring up Chrono Trigger. Roman brought up Chrono Trigger. And then now people are saying they're surprised I like Chrono Trigger, but I don't even know Chrono. I've never played Chrono Trigger. I do like a good JRPG, though. I quite enjoyed Final Fantasy X, for example. Not that that has much to do with Chrono Trigger, but, you know, point being. I also love Wild Arms 5. Wild Arms 5 is probably my favorite JRPG. That game is awesome. All right. Moving on. Yesterday, we finished going through our code base using the new memory analysis that we added so that we could clean up anything that looked like it was wrong. This is the first time we've been able to really view how our memory is being allocated, and there are some things I spotted I just wanted to take a look at. So we've got all that working now, and the only thing that I wanted to do today, and so that next weekend we can start on some entity system stuff that we'd want to do, that sort of motivated having this this memory view available. What I want to do is finish up that memory view so that it provides a more reasonable display of the memory, because right now it's sort of just hacked in there, and it doesn't really display the memory the way I would like, and so since we did all this work, I want to make the display good. So if we look at this part of it, this part of the memory display seems pretty nice. There's a couple things I think I would like to change that we might add today. But we added some pretty nice stuff in here. First of all, you can toggle whether or not you see debug allocations. And you can also toggle whether or not you have call site analysis in there. So this would basically tell you, okay, what are the... Why can't I want to actually... My head was in the way. I couldn't interact with my own application. So with the call site attribution on, it's really nice. You can actually see for any given memory arena, you know exactly who is taking up all of the memory. So basically, you look at one of these things and you say, oh, in my game mode, I've got 67 blocks allocated, and there's 1,077 total allocations. Where are they all coming from, right? And we can see them all here. And that's really important because that allows us to go target anybody who seems like they're allocating more than they should be, or doing something that we didn't expect. If we see somebody in here who has allocations attributed to them and we're like, why is that allocating so much, right? This is a nice view for that, and it's pretty easy. Plus, we can always just turn it back to this, where it just gives us a quick heads up, so we can see our percentage usage and stuff like that. Now, if we go over to arenas, this is the part that's broken right now. Yes, we display all of our memory layouts, and you can hover over everything to see what's what. But the problem is it's not correctly sized. So what we do is every block of memory that gets allocated, the sub-allocations are correctly sized, but the blocks themselves are just always 1/4 of the window width long. This leads to bad visual information. It leads to the fact that, for example, this, which according to the byte readout there in the hover, is around 3 megabytes worth of data, that takes up the same visual space as this, which is about 1.7 or 1.5, I guess, megabytes of data. And we don't want that. We want 3 megabytes to clearly be like twice as large as 1.5 megabytes. That should just, that's just common sense, because otherwise, even though we cognitively know that that's not what's going on here, when we look at this, your intuition just always assumes that if something's, twice as big as something else, it takes twice as much space. Or if something's the same size, it takes the same space. That's what it's thinking. And so it's going to constantly sort of screw with our intuition about who's using memory and why. And so what we want to do is go in and fix that. That's what we want to do today. And while we're in there, like I said, I may want to add one thing to this, and that is that right now we do not currently track peak memory usage by anybody. I'd like to probably add that. It's not very hard for us to track a peak memory usage for an arena. And so I would like some way of tracking peak mem. And then we can display it in here. So like blocks, allocs, and this right here, for example, we could have like peak versus, we could do this printout twice, once for peak, once for not, current. And the reason for that is that if you look at like something like the frame temporary area, you look at this and you're like, wow, the frame temporary only takes 2 megabytes of memory, right? Well, we don't actually know how much memory the frame temporary takes, because we don't know, like, people can use temporary memory and then get rid of it, right? So if you come into a routine and you allocated, 50 megabytes of temporary stuff, did a bunch of crap in there, and then, ended the temporary before the end of the frame, this will still read 2 megabytes, and we don't know about that 50 that got used for just inside the frame, right? So I do feel like, we want something in here that just also has a peak meter, just to let us know, like, hey, this thing is 2 megabytes of sustained, but it peaks out to a certain amount at various times, right? That's just a good piece of information to have in addition. So I'd like that as well to add in here, and that's not very hard to add. But the main thing we want to deal with, like I said, is this right here. And so that's the first thing I'm going to start with today, is just let's get this thing displaying in a way that's not totally wrong from the standpoint of layout. All right. So if I pop back to 4Coder and I take a look at that particular routine, the one that's actually doing that, that's the interval, the memory interval drawing routine, right? This routine. And if you see how we wrote this routine, I started to say, well, we're going to need, this happened at the end of last stream, we're going to need something that can take a memory range and draw it into position. So what I want to do is be able to generate calls to this draw memory range, and I want to pass like a starting address and a one pass last address with a color, and then I want this thing to draw them. And I want it to basically just fill up the space proportional to how many bytes were being used. So the first thing I want to do there is effectively keep a running total of the amount of address space that we use up. And so, I'm going to call this @address. And it's not really an address per se. It's sort of like a virtualized address. Because we're stacking all these together, and we don't care about how the address space is actually laid out in terms of page mapping. That's the OS's problem, and not only is the OS's problem, but we don't care. It doesn't matter how our memory is like organized in physical memory, really, as long as it's there. There's not a lot of differences. Now, there are cases where aliasing for things like the TLB lookups and all these sorts of things can have effects on chips, so I don't want to be taken out of context to say that it doesn't matter how your memory is mapped ever. Obviously, there's certain cases where you do care about that, but generally speaking, especially when you're talking about at the page level, it's certainly not something that we're concerned about here. So when we come into the debug arena, this is how we're currently drawing, for example, our blocks. And so what I want to do is I want to make this address kind of move along properly as we draw the stuff that we're working at. And so I think maybe I would call this block address more specifically. And so in here, what we would do is we'd say like block end address, and maybe this is block like start address. And so the block end address here is going to be whatever the block start address was. And then what we're going to do is add however much memory is actually used in this particular block allocation. And so we have the size allocated there. Oops. And so this will tell us specifically what we need to know for, you know, where the block starts and ends. That means that when we go to draw this, it's a pretty easy thing to do. Once we implement this draw memory range, I can just call this with those two addresses and know that the block will get placed where it should be placed, right? So I'm going to get this out of here for now. I don't want this, right? What I want to do instead is just call draw memory range, and I'm going to call this with the profile rect we were given, and then just these addresses. So we have the block start address and the block end address, and I'm going to trust, oh, and also, of course, the block color that we decide based on whether it's suppressed or not. I'm just going to trust that draw memory range will figure out how to draw the correct number of bars in the correct place to occupy that space, and we'll talk about that part later. So then what I want to do is we go in here and draw the sub allocations out of this. Same thing. I don't really want to talk about any of this stuff anymore. I'm not going to talk about sub regions inside this block's rectangle. We're just going to talk about absolute addresses, and we're going to let draw memory range figure that out. So we're replacing this effectively with this. What I want to do is grab these, and I'm just going to put these up into this routine up here in case any of it's stuff that I want to use later, because this is the thing that we'll actually be drawing, those rectangles. But what I do want to do is say this part right here, draw memory range. It's, you know, I want this tooltip to still work. And so is in rectangles not going to cut it if draw memory range might draw multiple rectangles, right? I can't get a single rectangle back that tells me this is specifically where the mouse would have to be. There's going to be multiple rectangles, and I need to know whether the mouse was over any of those rectangles. So what I really want to do is just say draw memory range should itself tell me, did you draw any rectangles that contained the mouse? And if you do, oops, then I need to know. Then I can print out my tooltip. So this is rectangle also kind of moves up in here as something that we're going to have to do per rectangle that we draw in order to return the right information. So at the end here, you can see me updating where we were in the block. We don't need any of that anymore. We don't even need to keep a block index. That kind of goes away. And furthermore, the block Y also goes away, right? We don't need any of this stuff. All of this stuff is, and even the block dim, all of that stuff, the only thing we really need to keep track of is the allocation index, and the reason we need to do that is because we're trying to cycle colors so that no two blocks that are next to each other use the same color. That makes it easier for us to see where they are and what they're doing, right? Now there is something we may want to do with that later as well that we could talk about, and that has to do with the GUIDs. So there are some things we may want to, like I'm going to put to do in here. And really what I'm seeing with that comment is, you know, when we look at this map, I don't know how valuable it is to just have this rainbow of colors there, right? Because it's really not adding any information. It's just letting me know that there's different allocations. But since I'm going to put a border on everything, I can kind of see that already. So what we may want to do here is try to have our debug color table be indexed by which GUID, like which line of code, actually caused this allocation to happen. And that one, when we look at it, we can visually see, based on the color, if there's like a lot of, you know, this particular green, we know that there's a lot of that particular line of code doing stuff. And so I think we want to change to doing that, but there's a little bit of work involved in that. And so I would like to, there's a little bit of work involved in doing that well, I should say. Because we could, just use the, a hash on like the pointer to the GUID or something. But in order to do it well, what we really want is something that uses the GUIDs and only assigns colors to things that are actually showing up on the map and so on. So, we need to do a better job if we want to actually make that work well. Okay, so now we've got ourselves down to the point where we just need to fill in what this draw memory range is, and then we can go work on the draw memory range function, and in theory, when we get that working, the whole thing just works right. So if you look in here, we've got draw memory range. We know that alloc, each one of these allocations, right, this debug arena allocation, each one of these tells us both the offset and the size that's allocated. You know what I'm saying? And so if instead of using any kind of sub-region of the rectangle, we just use the block start address and produce based on this, where the addresses are that are covered by this allocation, we can just call draw memory range the same way we called it before and have it properly draw the region. And if we then use this color that we have here, I'm going to call that alloc color, actually, we should be fine. So if I have an alloc start address here, what's that going to be? Well, obviously it will be the block start address plus whatever the offset is inside that block, which I have, right? That's where this would start. And then similarly, the end address is just going to be the start address plus however big it is, right? So pretty simple. All I had to do is compute those two things, and now I can call the same function. Since I'm calling the same function for both, that leaves me in the nice position of just having to implement one function called draw memory range, which figures out where inside the profile rect we have to fill in order to show that region. And there's a couple different cases that we have to sort of handle. All right. So sometimes with something like this, these routines can be kind of complicated. So sometimes it helps to enumerate the cases that we need to actually handle. And effectively what we know is we've got a memory range that's going to occupy some portion of our memory rectangle, right? The total memory display. And what we know is that that size could be anything. So it could occupy multiple rows. So the first thing we know is that we're going to have to fill at least a rectangle in one row, but we may have to fill multiple rows. So we know that we have to start with a for I loop that loops over all of the rows that have to be filled. And then on each row, we know we have 3 possible cases that we could handle, right? One is that we have a rectangle that starts at the very start of the row because a previous row overflowed, right? So we started on the previous row, and now we're still filling in this row. So we start at 0 and fill, up to a particular point. We know we might fill the entire row, or we might start somewhere and go to the end of the row, right? And then finally we have wherever we end, we may just have a little chunk, even if we're not ending, I suppose. There's a fourth case, which is just some part where we neither hit the end or the beginning of the thing we're filling, right? So there's really 4 cases. Start at the beginning, go somewhere. Start at the beginning, go to the end. Start somewhere, go to the end. And start somewhere and end somewhere on that row. Right? Okay. So what we need to do is figure out how to produce those cases properly, right? We need to figure out how to make this rectangle thing draw that, right? And furthermore, we know that since we're going to be drawing these rectangles sequentially, it's not really very hard for us to see how this is going to work. If we have the rectangle that we're filling, if we force them to pass us the mouse P that's currently active, then, and let me just grab that here and pass it there and there, I can trivially, without doing any extra work, I can trivially change this to include the Boolean result that I wanted, where I just say anytime we draw a rectangle, if we're in it, we set the return value to true. And then, we're effectively testing all the rectangles for hit detection. Off we go, right? So what we want to do now is say, all right, while we're looping over these rows, we need two things. We need to figure out what the row min and max is, and then we need to figure out how much of each row we actually contain. Let's start with this, which is figuring out where we are. Well, we now need to define some basic piece of information, which is like how much space one row on our display should take up, right? So we need like a value that's like bytes per row, right? And so something has to be bytes per row. If we assume that we're allocating, a gigabyte of memory in a typical PC, that's not very much for a typical PC game, but let's say that, Handmade Hero doesn't have, Red Dead Redemption's art budget, so it shouldn't have quite so much stuff. If we're using a gigabyte of memory or something just to store art assets and the world and whatever, then the question is, well, how much space, can we afford for drawing each one of our rows? If it's like 20 pixels or something, how much space could we actually afford to use there? And in fact, let's actually compute this out. If we have, maybe let's say 800 pixels to work with or something like that, and we divide that by 20, that basically says, well, there's 40 of these rows, right? There's 40 rows that we could show there. So if we wanted to say that there was a gigabyte's worth of stuff, right, and we wanted, sorry, that's a divide there, and we wanted to draw a gigabyte's worth of data, how many megabytes per row would we need to do that? And it looks like somewhere around, maybe like a 32 megabytes per row would be a good number for handling that much information, right? And that's actually a lot more than we were doing before. So I believe before it was more like we were drawing something like 4 megabytes per row. And so I do wonder if maybe that's a little too aggressive. But again, this number is one we can tune and zoom. We can have like a zoom that we would do to, allow you to see it more specifically too, if you wanted to, right? So let's figure out how, let's just pick a number here that seems reasonable. Maybe we'll say that we'll go with kind of the current one, which was 4 megabytes per row, knowing that maybe that's a little bit low, and we'll do more later. So megabytes for, that produces the right number of bytes per row for megabytes here. And what that means is now for a starting address, it's pretty trivial for us to figure out what row it's on. We just say, like, well, divided by the bytes per row, right? And the one past last address, we could divide that by bytes per row as well, right? Okay. Now, I feel like probably we would want to say also in here, if starting address is not equal to ending, right? Because otherwise we don't want to draw anything. And similarly, we don't really want to go to one past the last address. We want to go to just before one past the last address, right? All right. So this will loop over all of the rows correctly, putting the, so giving us an opportunity to step through them. And at each one of these, we want to figure out how big this rectangle should be. Now, we know, based on the row index alone, we should be able to figure out the y value, right? So we can start by saying that this rectangle, right, the rectangle has a min y of something, and it has a max y of something. Well, the max y is the thing that we'll solve for, probably, and the min y would be, because we want to stack from the top down, the min y will just be whatever the max y is minus our row height. And in this case, our row height is going to probably be 20, right? That's what we were using before, I want to say. So anyway, so let's call that row height, and that's going to be 20. We're going to subtract that here. And in order to figure out where we are, we just need to take the row index itself and multiply it by that row height. Now, I suppose there's really no particular reason I can't do this all in 64. This isn't a particularly time-critical routine, so I suppose I can just do this and be done with it. All right. So now we have the ability to fill our rows properly, but we don't really know what columns, right? We don't know the x extents of this thing on any particular row. And so what we want to do now is figure out, we've got a starting address, we've got an ending address. Do those starting and ending addresses map into this row or not, right? And so one thing we could say is, all right, let's start with the min x at the profile rect. Oh, by the way, I need to add that in here. So the profile rect we need to start at the top of the profile rect, and then we subtract our row index minus our row height, right, as we go. So let's suppose I start with my rectangle. Oops, changed the wrong variable there. We start with rect min x and rect max x set so that they map exactly to the extents of the profile rect. If this entire row is occupied by us, so our allocation spans, multiple rows and it's filling an entire row, that would just be correct. So the question is, when isn't it correct? Well, we've got two cases that are pretty clear here, actually. If the row index equals the min row index, then we know we're starting somewhere in this row. So we should set this to actually be somewhere inside the row, not at the very start. And similarly in here, right, where we've got the profile rect max x set to the, the rectangle we're filling set to the max profile, we have the same thing. If, and I don't know why that spanned that, don't want that, there we go. If we're on the max row, then we know we end somewhere in here rather than going all the way to the end, right? So now all we have to do is figure out, well, if that's the case, where do we start and end? Like, how far along, right? Well, in addition to computing where we are by using the row index times the row height, we can also compute the row starting address, right? We can take the number of bytes that occur in any given row and multiply it by the row that we're on. And in so doing, we can come up with the total number of bytes that it took to get to the start of this row. At that point, the two values we were passed in, the starting address and one past the last address, can be mapped relative to the row. So here I can say, oh, the starting address minus the row starting address, right, divided by the bytes per row, tells me how far along this rectangle I went, right? So if I lerped that t value, right, this is effectively a t value, if I just lerped that, so I went from profile rect min x to profile rect max x, right, I would get how far I have to go across. Now, what you'll notice is really doing this operation, I could have, because I know that if I just set it to 0, right, I'm going to get all the way to the min x. So I actually don't need to do this. I could just always compute this lerp, right? And so this becomes a little bit more concise. I could just say, look, use this in the case where you can sort of see it here. In the case where you know that you're on the min row, just use 0. If not, use the actual computation of the ratio, and then do the lerp, right? And the same thing could be true for our max x, right? We could just say, and we could call, we could call this tmin and tmax as well. So same exact idea here. Check to see if we're on the max row index. And then we say if we are on the max row index, we want to go all the way to the end. Otherwise, I want to do the one past last address minus the row starting address divided by the bytes per row. And then I want to go ahead and lerp that out in the exact same way. Okay, so hopefully that makes some sense. And again, all I'm doing is just figuring out where those spans are. Now that we've got our rect, we can fill it, and we can test to see if we're in it. And that should basically be it, right? What's the problem here? Unlock color, oh, is a V4 though. There we go. Okay. So now we have to debug this thing, obviously. Not off to a good start. I'm not even sure exactly what... Yeah. Not quite sure exactly what... I guess that's everything stacked on top of itself. Alright. But, again, this is really all we have to do to finish this up. Okay. So... I believe, or I hope anyway, that we're passing this information correctly. Oh, you know what? No, we're not. So we have to start by fixing this. Our block start address has to be equal to our block end address at the end of this, right? We need to move forward every time we draw a block. We need to advance so that the next block starts on the end of it. So that's obviously, that was wrong. But I think we also have other issues. So let me just fix that first, and then we can work on the other part of it as well. All right. So it looks like we're still computing a little bit of a wrong sort of span fill here. So let's go try to fix that as well. So first things first, let's make sure these are sort of looking correct. They look pretty reasonable to me, right? We compute that start address as 0. We then compute the end address by just seeing how big the block is. We put all these inside the block, so I think that should, do it roughly. That looks pretty good to me. So I just want to make sure this stuff looks okay. So looking at when this gets passed in, computing the min and max row here, I mean, that seems reasonable, right? So, honestly, I don't see the bug right away. If you look at the min-max y, that seems to be right. But there's some weirdness here already. Like, I'm not sure why it skips stuff there. But it's not totally wrong either, so I don't quite get it. I also don't know where that seam is coming from, so we got some really weird stuff happening here. That makes it look like we do have issues. Well, all right. Let's focus more on just the basic parts here. So we know that these things are only supposed to be 64K long. So the question is, why are they showing up as so? Why are they showing up as like filling till the end of the row? Because it looks like maybe the min row max row is sort of at least somewhat correct, but this computation looks incorrect. Oh, it's because these are backwards. That's why. What I wanted to say, but for some reason wasn't saying, I don't know why this is. There we go. There we go. Much better. So what we wanted to say was, if it is on the min row, then we do map it in. Otherwise, we just assume it started from the very beginning. And the same was true of the ending. If it was on the end, we map it in. So those were just set to the opposite way round of what I actually wanted. but that seems like, yeah, just a simple kind of typo mistake. Let's see if that helps. There we go. All right, so now if we sort of look through here, we can see all of these folks, they're taking up 64, all of them taking up 64K, so they're the same size. We can now see this is that 3 megabytes. You can now really see how long it is. Same here, right? There's a big allocation, and you can sort of see that difference in there. You can see the gap. Then here's the huge allocation for Handmade asset, right? It's using like this huge amount of memory there. For the asset storage. So this is great, right? This is a way better memory map than we had before, because now you can really see the difference in terms of who is taking up how much memory. Now you can see the problem we have where we're gonna have to be able to scroll this or size it differently. I think what I'm gonna choose to do is just make them a little bit smaller, because I wanna be able to see them all at once. I don't really wanna have to scroll. I wanna be able to see this memory map a little bit cleaner. So I'm wondering if maybe what I could do is just change the row height to 10, maybe, and see if maybe that's a reasonable way to do this. I don't know. What happened there? There we go. And so with a row height of 10, it's a little bit easier to see. You can get everything into one view, which is nice. It is a little bit small, but that's okay, you know, for the most part. And so, yeah, like, I mean, that's a pretty good memory view. I mean, I think that tells us, like, everything we need to know. You know what I'm saying? It's pretty clear who's doing what and why. This asset storage, I think, is that's probably used almost exclusively for audio, which we're not actually using it for much audio at the moment, but it's there. But that's what we want to see. So looking at this, I'm actually pretty happy with this. It's this part too that I want to minimize as much as I can, though, obviously. And the reason for that is assets are what take all your memory in the optimal case, because you just have tons of art, tons of sound, tons of music. You want to just use as much memory as you can for buffering that stuff up, so you don't have to hit the disk or have loading screens or that sort of stuff. And so these parts... Oh, Bean, what's going on? What's going on, Molly? You okay, baby? For some reason, Molly's sitting here next to me. I don't know what she might want to play. I can't play right now. Sorry, baby. Anyway, so this is exactly what we want to see, but this is not so much what I want to see. And the reason for that is not because this is too much memory to take up. It's fine, actually. It's pretty small compared to this. But again, it's too big given the fact that we haven't built out our world yet. We have a fairly minimal number of entities in there right now. And so we can expect this to get like 10 times larger or something, probably. And if you think of what that's going to do to our memory profile, it's kind of a disaster. It's going to start to like bloat out a lot, right? And so we've got issues there. That's going to be a problem. So here's another thing I want to do. I think I can also help here by saying maybe we up it to 8 megabytes per row. Again, that helps us kind of visualize an amount of memory a little bit easier because we have, you know, a lot of allocations and stuff. All right. So there's our memory map, and it's pretty. I think that's pretty reasonable. I wonder if I can make it maybe just a little bigger though, because it's still a little bit hard to see in terms of the rows are a little bit small for my taste. Okay, so I think that's pretty good. All right. Okay, so all of this looks pretty good now. I feel really happy about that. I feel like that lets us see the memory map really cleanly. I've got the size in here. We don't have a per frame thing going on. We may really not need it. I may get rid of that. I'm not sure that I care. But I was going to add something sort of like the profile. So like this, right? You know, we had that thing for our, who was taking the time and why. So that, you know, would have been something interesting. But we just don't have a hugely fluctuating memory. Like, we don't really have that. So I don't know that we care about that too much, but, you know, who knows. So anyway, I think that's all good. And in here, I think the only other thing that I want to do is maybe try to color these entries by attribution instead of just randomly by allocation index. That seems, potentially more useful. So that's the only other thing that kind of strikes me as something that maybe we would want to do. Because all of these come from the same place, so we kind of want to see those all as one color. That seems like it would be a more useful thing to do, right? And the problem there is just we don't probably have enough colors based on the number of allocation call sites we actually have. If I look at this and I look at the number of call sites, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So, let's say there's 32 call sites in there or something like that. How big is our debug color table? Yeah. Yeah, I mean, our debug color table needs to be like twice as big as it is right now. And, that's a nice thing to have, so it would be cool to do something like that. And maybe we could, like, what if we just took all this and sort of made one where, let's try to do that. Because then we could actually see that memory map in a much nicer way. And I kind of want that to happen. So looking in here, right, like what if we just started putting in some like 0.25s as well? And so, maybe this is like all the zeros become 2.5s. So they're just brighter versions of the same colors. I don't know. We could also make all the ones be 0.75s instead. I don't know if that's good. I really don't know. I kind of feel like one thing... So here's the thing that would be a great handmade.h file, if anyone out there is listening. It would be pretty awesome to do a thing where you had a file that was just this. It was literally just this array. And it was like 100 or like 64 colors that had been tried to be balanced to be the most different, like the easiest to differentiate. So you try to solve for like a certain number of colors that will be differentiatable. Like write a little solver that just goes through and like tries to like place colors, almost like blue noise in color space. We should do that sometime. And then just have, it's like debugcolor.h. It's a 64 line file, right? That just has the colors. And that's it, right? Don't even put this. So people just do this. You know what I mean? That way they can be whatever struct name they want. That would just be a cool file, I think. All right, so this is a bigger debug color table now. And so I'm hoping that now what I could do is when I draw these memory ranges, when we come through and pass the color values, so the block colors I don't care about because those are not the interesting part. What I care about here is this alloc color. What I need to do is have this alloc index, the color index basically, get assigned to a particular allocation based on the GUID in question. So based on the like line of code that thing is coming from, right? And so I think what I want to do is track these things more specifically and allow them to get indexed in some other way. So, for example, bear with me for a second here. If you look at how I was doing this before, right? Remember this call site thing? Basically what I was doing there is I was tracking the call sites dynamically. You know what I'm saying? So, going through the memory system, you know, these things don't know, it's just this. It has no idea what that GUID was, right? Well, what if I did something more like this? So we track the call sites here. and we deduplicate them right at the time where we actually look at them. You know what I'm saying? And that way we can assign each one an index. You know? So that way we just always could use the call site data for doing things like a color lookup. And furthermore, like in here where we do like the push struct, right? We wouldn't have to hash this anymore. We could just use a direct lookup into that memory. So for example, instead of having to do a hash, right here, like with this call site hash thing, that's actually a thing we could move out to here. And this wouldn't have to be a call site hash. Instead, this could be call site stats, and it would push a flat array on that's just the size that it needs to be. So taking a look at the debug state, there would just be a variable, like a counter. There would just be debug arena call site count, right? And then you would just know that these would be indexed. Make sense? So I think that's kind of cool because then we don't have to worry about the hash anymore. We'll do that sort of as part of the process to begin with. And so then here, where we are actually making these hash things happen, we don't actually have to do that anymore at all, right? We'll do that out of line. When we accumulate the statistics and we want to allocate them onto the, do that onto the site, we can just straight up look at the call site directly in the call site stats. So here we just say like, okay, the call site stats for this alloc call site index, we just directly use that array index to accumulate the statistic. And then when we come through to the place where we're actually printing it out, we no longer have to loop over the call site hash size. Instead, we just loop over the individual call site specifically. So yeah, basically this. So that feels way better to me anyway. So that like improves this as well. So I think all of that's just much better, right? Yeah. So yeah, the call site stats now probably want to be a different name, right? This probably wants to be that. Just so we're clear that this has nothing to do with it. Oh, and actually, we don't even really need that anymore, now I think about it. Because this doesn't really need any of those things, does it? Oh, well, it still needs this. Because it does need to check to see whether that particular arena whether it's in that particular arena. So yeah, I guess I still do need that. I don't need that. So yeah, that works just fine, but the problem is now this thing does need to know that particular piece of information where we've got the GUID and the allocated part. What I would really like is to just be able to get that from the index itself. So let's make that happen, because I think that's just better. So let's just make this be a debug statistic. Because that's what I want. So I want to be able to just say, look, here's the debug statistics. I'm going to push an array of those on there. When I come through here, we're just going to go ahead and increment the stats. And then what I want to do here is I want to print out the stats one by one, but I only want to print them out for this arena. And that's the tough part, right? So we know that we can get the statistics pretty easily like this. But the problem is, how do we do this test? Right? We need to be able to look that up separately. And by the way, this is all this. So we need some way of getting the site here so we can look at which arena the call site belongs to in this case. And we need so we need like debug arena call site. You know what I'm saying? So there is one other thing there, well, no, not really. We're gonna not care about that. So we need some way of getting like get call site from index, right? We need to do this. And I think what I'm going to do is just cheese out on that and make that be like a cheese call where it just loops over the hash table or something and grabs it. I don't know. I'm trying to think if there's something else I want to do here, and I'm not sure. I guess we could just use this as an array since we know it's fairly small. So in here, we're going to say if the debug state, if the index is less than the debug state, arena call site count. Then we would say debug state like arena call sites. So we can like access them off of that index, I guess. Again, I'm really not sure how I feel about that. Maybe kind of unnecessary. But I feel like we kind of need it. So I feel like that's pretty good to go. And I don't know that there's anything else particularly weird that has to happen there. So really, I just need to actually build that hash table when we're actually collating the arena information in the first place. I need to build that. And then I would have those indices assigned properly. But I think that's the only other thing that's missing now from allowing this to work, right? And yeah. And I think that's all good. So if I come up here and just grab the part of the code that we were using before, so, inside here when we're doing our collation, we have these calls here. Which is, where is it? This. So in here, what I want to do is have a way of, processing this, this bit of information here. So I need to handle these call sites, right? So these probably have this. And they probably have this. Like so. And for each one of these allocations, since I'm only processing allocations that actually happen here, and there's not that many call sites, I almost say we just linearly search the call sites. Instead of having a hash table. It just feels, I don't know, like the amount of time we would waste maintaining the hash table, I think it would just be better to linearly scan. You know what I'm saying? Because we just don't have that many allocation points. That's my guess anyway. So in here, what I would do is say debug arena call site. get call site from. And what you would do is you would pass the GUID and the debug arena. And the debug state here. And then we would just look to see, is it in there? So I would just linearly scan first the site index. I'd say, you know, debug state, arena call site count, site index, have the result pointer here. If we don't find one, we'll make a new one, and off we go, right? So we know that this is the part where we make a new one. We know what that looks like. It looks something like this, right? And we know that we have to like make space for it. We don't need the hashing anymore because I'm just not going to do that. And so really we just need this part. So as we loop over the sites here, what we would want to do is, here's the debug arena call site that we're testing. We would do the arena call sites plus the site index. That's the one we're testing. If it matches what we're looking for, then we found it and we're done. Otherwise, we would have to create one if we errored out of there. And so the only thing we've got left to do is figure out how we're going to store these in a linear array. I would say let's just make space for one because we know we have fairly minimal number of allocation points. I would say let's just keep it simple, right? So let's see. I'm not sure how many we want to do, but again, since I'm doing a linear scan, I think we want to put an assertion in here and basically say, look, if you blow out the number that we've got, I need an assertion because I probably have to, then I probably do have to change it to a hash table at that point, right? So debug, actually, arena call site count, and then we need debug arena call site, arena call sites. Actually, I can just do it like this. And let's just say we don't want more than 64 of those. So if not result, we need to assert that debug state arena call site count. And, you know, I guess I don't know for sure that we're not going to blow that out because we're not seeing a bunch of those allocation points. So again, it may be that we do actually have to add, you know, it may be that we do actually have to add that in there. I don't know, and do a real hash table. We'll just see. We'll play it by eye, play it by profile, and see what actually happens. All right, so let's see. Here's the call sites. We need the arena, the GUID, and the index. We don't need next in hash at the moment, and we don't need to push. So I'm just going to say let's assert that this thing fits. And once I assert that, I'm going to take the index and say that the index for this particular one is you know, whichever one we would pop, you know, push on next. And then the result pointer is just that one. We would then set all its parameters up, which is just these, and we don't have the hash at the moment. And then we'd fall out of there, right? So now I got to go fix all my compile errors, and then we should be good to go. I want to stop this. So let's take a look. The call site pointer for this arena allocation probably should just be a call site index. Actually, so we can just do that. All right. So here where we've got our alloc, right, the GUID for the allocation, yeah, so this stuff doesn't actually exist in here. We have to get the call site in question, which is fine. So all we do there is we say like debug state, debug arena call site, site equals, you know, get call site debug state alloc, just so we can get the call site for the alloc. And then I would just say, look, there's the GUID, and off we go. So that just wants to be, you know, a function that's really simple. Debug arena allocation. And all that's going to do is say, do the same thing, but pass an index. So assuming that you're doing something you actually can legally do, meaning you're passing one that actually exists, just so we know if we screwed anything up, you get it back. And then this is a convenience call that just says, all right, if you pass me an allocation, I'll go ahead and deref that for you. And off we go. So those should make it easy for us to work with these, and then modify how we're storing them if we want to. Arena call sites, I think is what that's actually called. Okay. So let's see what we've got here. So call site now, right, is not, because it's the index that we actually care about. So in here, where we do debug arena allocate, we don't want to set a GUID anymore. What we actually want to do is say that the call site index equals get call site from, and then we would pass that GUID in here. So we know what the arena is, we know what the GUID is, and that should give us back the information that we wanted. We can make this return a U32 as well. So here we could just return the result index every time. And then finally here, where it's looking at that call site, what we actually wanted was the index anyway, so we can just use that directly now without actually dereferencing anybody. And I think we're now good to go, right? Barring bugs that I almost certainly inadvertently put in there, we've now reorganized it so that it works by tracking call sites through the entire pipeline. I gotta switch to a debug build to debug this because I don't really want to deal with the bad debug information that the optimizing compiler spits out. So let's go ahead and do that, and now let's figure out what we screwed up, right? Okay, so we've got too many call sites, first of all. Of course, I don't actually know. That could be because this is wrong as well. So it's hard to say right off the bat, but let's take a look. So here's that GUID. Here's the debug arena. So there is something a little bit bad about this that I kind of forgot about. And that is that we probably do need to make the GUIDs do a string compare in this particular case. And the reason for that is because the GUID pointers won't be stable across reloads. This wasn't a problem previously because they were not actually yeah, they were not actually being stored permanently. They were being computed every time we wanted to print them out. So that's less good, right? All right. Anyway, so really this needs to be that, which is not what I would have wanted, but oh well. So in here, I'm going to just up this limit till it works just to see where we're at. And then we will maybe put in that hash table back in because it looks like it might be something that we actually do want if there's really that many of these things. And I guess there are because now it works okay. So that's how many we have in there, I suppose. So if I go ahead and change this to 02 here, let's go ahead and take a look at those allocations again and see where we're at in terms of actually tracking them and whether I screwed anything up there. So if we look at the memory and we take a look at those call sites, like here's us tracking those call sites properly. So actually, I guess I am glad we did this though, because looking at that, what you can see is that now that we track these always, I can start to keep peak allocation numbers for these things because you can see all of these places that allocated stuff and then deallocated it so that current outlay is set to 0, right? So I am kind of glad we did that. It wasn't unnecessary, I guess. So now if we look through here, hopefully I can now figure out a way to make this thing produce stable colors, right? So looking at this, I'm doing something stupid right now. I'm just not sure what, because if you look at all of these, you can see that the call site index is actually the same, as far as I can tell. But I'm getting different indices, and that's not supposed to happen. So either I messed up the call site indexing somehow, I guess, but I don't know. Or I'm like picking out the alloc index wrong. Oh, we never used it, so never mind. There we go. So now we're using the call site index specifically across all call sites to try to color code this. And again, it's not perfect because we don't probably have enough colors to actually fill everything in. But now we can see it's still quite a bit better, right? Now you can see that all of these are taken up by the same piece of code, and that's just a lot easier to understand, right? Because now you know that all of these are the Handmade world, allocator there. Okay, so I think the last thing I want to do, I don't know how much time I've got. I've got probably what? 45 minutes, let's say. Let's say 45 minutes. So I would like to add in maybe some peak timing, and also we probably need to make this thing scroll, right? Because I can't like see the rest of it. So we probably want to, and we also probably want to get rid of this because we're not really going to use it, right? Yeah, that seems like the right thing to do. I don't know. Yeah, that seems like the right thing to do. The other thing we might want to do is actually compute all this information. We might want to actually compute all this information in a shared format between the two routines, because like when you hover over this, it might be nice to get that percentage. Like, hey, this is the like usage of this thing. And by the way, here's the percentage that equates to, right? So that feels like probably a good thing. Yeah. All right. So I pretty much finished what I wanted to do today. So I think we're just down now to, I guess just gravy. And then, because I don't really want to start on something totally new. Hey, look at that. Now you can see the debug usage pretty cleanly too. Right? We don't track what's actually happening in there because we can't. If we did, it would overflow itself. But at least we can see like cleanly who's using what, right? And that's pretty nice. So yeah, let's just go ahead and go in there and clean this stuff up. I also am wondering, like, can we just not, like, can't we just, there's got to be a way to change how we're doing the, I don't want to have to click on the profile to, like, open it up. So surely there's a way to make those things be expanded by default, like, I don't know. It's been a long time, and this part of the system is the crappiest. So maybe not. But I'm just curious to know if there's a way to force that to be expanded by default instead of not. So if I take a look at the debug interface stuff here, in fact, I think there was sort of a expanded always. You can kind of see these in here. So you can see, like, when you do toggle expansion, you've got this like view collapsible expanded always, right? And that's from an interaction. So if I just take a look at the Handmade debug stuff here, where we actually create these, when we get back one of these groups, right, we're doing create variable link. And so that has a debug element in it, which I assume, I was going to say there should be some way to look at like what the ID of that is, right? Or maybe not. Get a create debug view for. Let's see how that actually works. So I guess the way this works is it just says, hey, we hash something, we hash the dev ID of whatever the thing is that you're clicking on, right? And so the question is, how do you get a dev ID from one of these things, right? Like there isn't one in here. And there does need to be one of those. And so looking at when I actually create these, I'm guessing that like these groups, see, these groups have to get placed somewhere too, right? Like they have to be put at the top. And I'm just not sure where that's getting done. So this draw tree here, I guess that is really the thing that we just want to always be expanded, really. And so if we have that, surely there's some way we can force that to expand. Debug ID from link. So I think that's all we really needed. Probably. So as ugly as it is, like I said, this system just did not work out very well. I feel like we could clean it up tremendously now if we really wanted to. Since we now know what we actually want, it can just be simplified. But each one of these things can be asked for as individual trees, right? Since we know what the tree is here that we're actually using, which is to say, although even that's a little bit weird now I think about it, because that tree isn't really there either, right? Such a stupid system. When we're drawing that tree, it's like an ignored tree, like a nonsense tree, right? So even that, I don't quite understand how that should be working. Yeah, that's really weird. When does this first... Yeah, so I think that's just kind of garbage. It's using like this debug tree, which is a ignored like non thing, and it's remembering, but only based on that, which is just kind of luck that works at all, I think. So like, you know, when this thing, I assume, wraps the tree handle in there, yeah, it does. So this is just ridiculous. I mean, really, if you wanted this to work properly, which I suppose we do, for the time being anyway, in here, like, you would want to put like a, you know, a HUD tree or something like this, right? And then when you drew this thing, because you need a stable pointer there, so this thing should look like that. You know what I mean? And that way, if you wanted to, you could do you could do like a toggle on that now, where when you do the debug init, you could do like a expand, and you just say this one here, and for that tree, you want it to be set to be expanded, right? When it's being used as the HUD tree. You know what I'm saying? So really, yeah, really stupid, but that's the idea. And so given those, we just need some way of setting that expand always to be this part here, right? That. So I think what we want is something that looks like this. And we'd pass the debug state and the dev ID. It would do this and set it to whatever we asked it to do. which I guess doesn't need to return anything at all. So we just need to do the one call that says like get an actual, get, what was it called? Something for link, get ID for link, get dev ID for link. I don't know. Something like that. So you just need to call this thing. And you have to pass that. In fact, it's this. So I guess that's it. Again, really crappy, but that's what we're dealing with. So now that we've got those, I think that would be expanded by default, right? And oops, sorry, that's memory group. And that way we don't have to manually drop them down for no reason, because we don't ever really want to, if I pushed that F key, I wanted to see it, right? Although, now that I say that, they don't do that. So why not? That should set the expansion state, right? On the HUD tree. Get a create debug view for debug state. Oh, well, I also don't know if this needs to be done a little bit later, I suppose. But I don't think that should really be the problem. I don't think that should be the problem, though. So I'm going to have to go look at why it's not looking them up in the same place. Hold on one second. Yeah. Because, okay, so when we set those, it's on the HUD tree, and it's profile group and memory group, right? Which are the things we're actually displaying. We're setting those to be expanded. That looks correct. So I think that should be right. But of course it's not. And let's just see what happens here. So we actually need to start a debug end. You can see here we do a draw tree call, and we pass the HUD tree with that, with one of those. So since we're passing the HUD tree and that link pointer, what's the problem? We come in here with the same variable group, right? And we call draw tree link on it. So here's draw tree link. We have that, again, this right here should be one of these, like it should be like memory group, right? So then we say like, well, can it have children? If it can, then we're going to do some stuff here. If it can't, then we're just going to draw it. So we know it has to have children because otherwise we wouldn't see any of those pieces when we do drop it down. So we ask for the debug ID from link, which I'm arguing should give us the same thing we had before. We'll then call get or create debug view for, which will be this, and here's the view. And then, we'll check to see whether it's expanded always, and if it is, we should draw the children, right? So what I don't quite understand is how this didn't do exactly what I wanted, because it should have, and we should have gotten into here. So I guess I got to step into that and find out. So let's see. I'm going to go set a breakpoint. I'm going to set the breakpoint on, let's see here. On this draw call, well, actually, no, on that draw call, yeah. And then I want to do it on these. So I come in here, and we're going to call setExpand. So we produce a debug ID for one of these guys, and I want to see what it actually ends up being. So there we go. Let's see. We set the tree, and we set the link. I can now copy these, I think. Yeah. Thank you to George for that. There we go. So this is what we're setting our ID to. We then go getter create debug view. We hash this thing. There's nothing in that hash slot, so we make a new one. We record the ID. We say that we don't know what type it is, and then we... Oh, well, interestingly, the fact that we don't know what type it is seems less good, because shouldn't we set it to a particular type? That may be part of the problem. So when we got this view here, how did it know that it was, you know, let me yeah, like, how does it know it can look at this as a collapsible in the first place, and does that have to get sorted out by anybody? I'm gonna take a look at that. So who ever looks at this thing? Just curious. I mean, it should be set to that, right? But of course, the fact that nobody uses that means that the fact that we're not setting it shouldn't matter. So I don't really know what to make of that. So let's see. We set both of these. We set to expanded always. And that's fine. Let's run to the where we actually draw this thing. So inside here, this should actually not do anything because there is no group, right? So we actually need to do that. Then when we run this thing, I will now switch to one of the views that we actually expect to draw there. So now we're going to go into this draw tree link. So when we come through here and produce this draw ID, and then I'm going to try to get one of these, I should find it, right? So the fact that I don't find it pretty much tells me what I need to know, right? It's the fact that these IDs didn't match. The one that I set at the beginning doesn't match the one that I'm setting now. But I don't know why, right? So if I look at this, I'm doing a debug ID from link, and I'm passing this tree pointer and this link pointer. But those should have matched because, you know, the tree and the group came from here. and it was this, which should be the same, although I guess we'll have to check. And then it should have been this, which also should have been the same, right? All right, so one more time, let's just see why the ID doesn't match. Stepping into here, here's what the ID looks like. Just right here. Copy that. Copy that. So this is what our ID should look like. And now let's go see why it doesn't look like that. If I now run to... this is the profile, so is that the first one? I did the first one, right? So I need to make sure that I'm looking at the correct one. So let me just see. Yeah, profile group. So when we come in here, now I'm going to build that UID again. So here that is. So that is the same. So the tree is the same. It's the link that's not. Right? So the thing I expanded somehow wasn't the same thing. And of course, how that's possible, I have absolutely no idea. You can see here that we're setting that link to debug state profile group. And I'm setting the link based on that. So when we actually switch to dev mode profiling like here, how would that not produce the correct results? Now, I suppose I may have to look to make sure that that doesn't get changed somewhere. And I'll be honest, I'm not sure what could possibly be happening here, because it just gets used. You know, I don't really know. Let me look at that debug UI HUD function there. Not that one. So what do we do on set HUD? Oh man. Wow. Yeah, this system just sucks. So for whatever reason, we create a dummy group that sits in there, but then we just replace it later with a different one. Why we create the group, I do not know. Like, what the point is of that. Just seems dumb, but hey, that's what we do. That means what you actually want is this, which is to say when you create a HUD group, we just assume that you want it to be expanded. Happy birthday. And so that gets expanded right here, right? Another way to do that would just be to say, hey, the default parent group, that thing, that comes in there, right? And then this set expand function, you know, I don't know where this should go, but somewhere at the top here, probably lots of people would call this thing. Let's see, I don't know, something like that. Oh, actually, I guess it has to be. Gotta create debug view for. All right. so I think that was a extremely roundabout way to do this, but hey, we did it. And so now I think we should be good to go. As torturous as that was. Should probably do a marathon weekend sometime where we just clean all this code out. We now know exactly what we want, and we could do such a much better job. So now at least these are open by default, right? Which is what I wanted. Because there's really no reason not to. I feel like these should also be longer by default. Sort of a separate issue. All right, so let's maybe now go in and when we look at this stuff, right, I maybe want to go ahead and get rid of this frames because we're not going to use it. And then for call sites, so again, looking at this, I think what I might want to do there is set something up where we look at peaks for those. And so maybe we take a look at some of that stuff. So let's look at tracking those peaks, and then also maybe we can have a thing that sort of says, in addition to those buttons, maybe we'd have a thing where we allow you to pick a couple modes, like don't show me anything that's not persistently allocated, you know, and stuff like that. So let's go into the call sites and try to figure out how to get the allocs to happen there, or the alloc tracking to happen, so we can track peak memory usage. And we can also probably do that per arena. That might be the easiest way to start, is just do it per arena, and then we'll add it for the call sites later. So let's start with that. Inside Handmade debug, when I'm tracking memory, each one of these arenas, I'm going to say that maybe we just have a peak memory, like cur total alloc and peak total alloc, something like that. And so whenever we allocate a block of memory, so when we have blocks allocated or freed, we will adjust that peak number. So probably like trying to think how I want to do this. So when we do an arena block allocate, we would say that the arena cur total alloc is going to be whatever the block allocation size is. It will go up by that much, and if the peak total alloc is less than that, we'll remember that as the high watermark for the arena. And then when a block is deallocated, so like in this case, what we would want to do is say whenever we remove the block, we subtract off like however big that free block was, we take that back away from the arena's total allocation outlay. So that should allow us to just track the total usage over time, the maximum that any arena ever hit. Even if it doesn't end a frame there, we'd still be able to see it. And so then when we draw those allocation numbers in, so when we do top mem list, for example, in addition to the basic statistics, we can have that piece of information. So you know, the peak, here's the regular, and then we also maybe have a peak. So we do a percent for UMB for peak as well. So that's arena peak total alloc divided by F64 megabytes 1. And then here what I'll do is I'll just say like 1, 2, 3, 4. I need to put like, you know, cur, and then peak, something like that. And that way now I should be able to see the peak for every arena in addition to the amount that it's actually sort of using at that time. And, oops, didn't mean to set a breakpoint there. Probably an old one that got moved down. So then, oh, I forgot the MB, so I can push these a little further. So, yeah, that's exactly what I wanted to see. Hold on a second, let me push those over a little bit. I think that's it. So this is exactly what I wanted to see. For asset storage in game mode, it's exactly as what we would expect. The current amount that's used and the peak amount are the same. And of course, the reason for that is because those are persistent storage systems. So you don't expect them to fluctuate much during a frame. They're just allocated and that's it. But then on frame temporary, this is exactly what I wanted to see. You can see that it ends the frame with only 2 megabytes used, but there's actually a really large amount of memory getting used in there that happens as a transient sort of occurrence inside the frame. So that helps us understand that on certain frames we use a lot of memory in there, perhaps every frame. That's a lot more than the amount that we're using just as a stationary storage across the frame boundary. So what I'd like to do is then just continue to expand on this. When we come in here, you can see that we don't have peaks for call sites, but there's no reason why we couldn't have peaks for call sites, I don't think. So let's see if we can go ahead and put in peak tracking for call site data as well, so that when we print this out, we'll be able to get that number in here too, right? Okay. So if we're going to do that, we would need this percent for UMB to happen down here as well, right? And so we would need this. And when we print out this value right here, we need to know, like, all right, like what's going on. So we need like peak total alloc. We need that to be on each individual call site. And so if I go out to where we're tracking the call sites, we know what we need. We need this, right? And off we go. We could track the cur total alloc as well. I suppose there's really not a reason not to, and then we wouldn't have to do the call site looping. Well, we can do that later. But anyway, this peak total alloc here on the call site, if we wanted to track that the same way that we were tracking it per arena, we need to do the exact same thing we did before, except it's a little bit harder because on every single allocation, we actually need to take whatever the call site was, like this, and we need to inc that, right? So we need to do a thing where we have like debug arena call site equals get call site debug state call site index, and then we need to do like site, just do that down here, site peak total alloc plus equals whatever the allocated size was, right? And so in addition to that, we also need up in here where whenever we like remove one of like the links, we need to process that. And so I believe that always goes through debug move to free list, And so in here where we do this, we're now regretfully, and I suppose it's, you know, it's fine. We have to loop over each of these. And remove it. Now, actually, this isn't quite right. I think we actually need to do it more like this. Oops. Because we need to also process the last one, right? So I can't stop before doing the last one. So for each alloc, I would need to say, take the call site in question for this particular alloc and remove the size that this alloc represented. You know what I'm saying? So as long as everyone always moves allocations to the free list, which I think they always do, that should take care of it for us. So on truncation, you can see it doing it here, and on block free, you can see it doing it here. So I think that would track the peaks for us, right? So if I go in here and look, here's the peak tracking. It does look pretty reliable, right? Now, of course, we end up with our scrolling problem. I need to be able to scroll this list. I can't actually see it here. And there's another thing that we probably would want to do if you look at how this is laid out. We probably want to come up with a printout. 0 megabytes, not a helpful number, right? If it's too small to list in megabytes, list it in kilobytes. If it's too small to list in kilobytes, list it in bytes, right? So that's another thing we can do here. So we need two things. We probably want to be able to scroll this thing up and down. And the other thing that I probably want to do is I want to be able to... and I assume we want that here too, right? Like, it would be nice to be able to scroll that up and down. So I think both of these probably want that, right? I mean, that's seems pretty straightforward. So we should probably add that. But anyway, it looks like the peak tracking is working here, at least somewhat. And you know, it's a little bit hard to say because we don't have something to compare it to know if that's actually true. But you know, yeah, maybe. So I'm going to do two things. I'm going to add the scrolling, and I'm going to add the ability to print the instead of like you know MB or whatever. I want some way of printing that out better. And so, you know, I feel like this is a place where maybe I can lean a little bit. I don't know, maybe I can't. Lean a little bit on the fact that we have our own printout here. I'm just kind of thinking, like, when we look at these values and, you know, I've got all this stuff, you know, could I just add my own % format specifier? So, like, instead of U here, I could just do B and have that work, right? Or maybe %M for memory. I don't know. I'm a little confused about the read var arg unsigned integer part of things. The reason I'm a little confused about that is, does that read 64 bits or 32 bits? So it just uses the length specifier here. But I could say that mem was always supposed to be U64s, probably. I don't know if that's what we want or not, but I don't know, man. Don't look at me, I just work here. So I'm guessing I want to do something, yeah, you know, vaguely like this. So if you pass one of these things, it's like a memory-sized thing. You know what I'm saying? And so we'd say like, all right, this is actually a 6M instead of a 4UB, and we're just assuming that you add the little like stuff to the end to say what the heck it was. And so when we do this conversion, we would just say like, all right, convert, you know, U64 to ASCII. I pass the value and we do our little dance, and then I'm gonna, into the temp desk part of things, I'm gonna stick some extra stuff. And so what I want to do here is just figure out, like, you know, my suffix is just going to be like B with a space, I guess, for bytes, right? But then what I want to do is like keep doing some tests here. So like if value is greater than 1024, then my suffix goes up to be like KB or something. And my value, I divide by 1024, right? Something like this. In fact, we probably want to do it... Well, I don't know what I want to do. Don't quote me on that. Right, and then we would do the same thing again, probably. Like, if the value is greater than 1024. I guess, you know what I could do is do this a little bit more stably. I could say, like, if the value is greater than, like, a megabyte... You know, if the value is greater than a gigabyte, like that. And then each of these things just does like whatever the thing is that you do. You know what I'm saying to you? And so I could just say if it's greater than a gigabyte, then the suffix is going to be gigabyte. And the value is going to be, you know, equal to the value plus gigabytes. 1 minus 1 divided by gigabytes. Right? So we round up and we just say, like, that's how many gigabytes it is. Now, you might argue we should, like, put in a fractional thing here, and you're not wrong. But we're also not going to because we're out of time. And so then, if I go look at U64 to ASCII, one too many of those. If I go look at U64 to ASCII, you can see this outchar thing. So the outchar thing, I just now need to add that, you know, those sort of, that suffix onto the end, like so. And I think that's it. So I think that should now print out the values we're talking about here. Let's go see here. I'm having some kind of an issue with the VA arg list. What's wrong with that? Shouldn't that work? Not sure I see what the problem is here, but obviously something is the problem. We're using this, right? I mean, this is what other people are using. So this code right here expands to, like, if length equals 8, VA arg list U64. That's what that expanded to, right? Hold on one second. Let me just make sure there's nothing else weird going on here. Is UMM, like, not defined or something? Oh, okay. Yeah, I guess it isn't in this code. So what's up with that? Is it not defined in Handmade platform or something? So it looks like it's just really confused about what's going on there. So this looks like the problem, because I'm assuming, yeah, in Handmade shared, Handmade shared is like not actually. Well, no, this is Handmade types. So UMM should be totally valid, right? I don't get it. What's the problem? So all that stuff works fine. There's a UMM right here. Did I just like... There's a missing colon. That was a really bad error message. Wow. How about just missing colon after case? All right. So let's see if this helps at all. I don't know if it does or if it doesn't or if it will or if it won't. That is not 556 gigabytes, in case anyone was wondering about that. Let's try that one more time. So we look at whether the value is bigger than gigabytes with the suffix on there. Let me take a look at what where we're calling that. So these were cast to U32s, and they should not have been. Oops. And we need to actually pass them as UMMs. So that stats sum, that actually needs to be converted to a UMM, right? In fact, this one doesn't because it already is. But they need to be passed as UMMs to that, so I'm just going to make sure that they are. And the same would be true here. Again, we don't need to do this anymore. So I believe if we just make that a 6M and that a 6M, now we should get those printing out properly. And again, this is just a way to make it so that it's a little bit easier for us to figure out what the heck values we're dealing with. We don't have to like always like try and go, oh, is that bytes? Is that this? Is that, you know, something else? All right, so these look right. This looks a little suspicious. Although I guess we just do greater than or equal to. It might actually be true. They might have just allocated one 1K block. In fact, they probably did. This makes it a little bit easier to see what's happening right now. Some of these things that were just 0 before, you can see like, oh, there's a 4K. That takes up 4K's worth of allocations instead of 0, right? And here, you know, you can see, oh, there was a 32 byte allocation there for something, right? So it's a little bit better than it was, but it's still not quite as good as I would like. Let's just try one more thing in there and say that this is greater than or equal to instead of greater than. That's probably more sane, but that seems good. And now we'll go ahead and go to Q&A. Yeah. And that looks better. Okay, let's Q&A. Do you think that having a way to visualize the memory as an image could be useful? How would you implement that? I don't know what you mean. Like, how would that be different than this? Do you mean like you want to draw like the values that are in there or something? Do you mean like the contents of memory? And as far as whether I think that'd be useful, I mean, it might help you see things like runs of zeros and stuff, or something. But yeah, I don't know what you would really do with that. Um, yeah, I don't know. But if you wanted to implement it, I mean, honestly, it's pretty straightforward. You would just, and it's, how you would necessarily make sure that the speed is what you want. I don't know, but, you would just say to OpenGL, here's the arena start address, and here's how long it is. It's a texture, and it would download it to the card, right? I mean, that's it. It's memory, so you just draw it. And I mean, you would probably want to draw it as mono, so you'd probably tell it was a mono texture, because you don't, unless you want red, green, and blue to mean something, you just draw it as a mono texture, and then you'd either just be fine with grayscale, or you'd use a lookup table to map like 0 to a specific color, and then 1 through 255 to some other color, so you could see the difference between zeros, maybe zeros, ones, and something, or something like that, right? Short of that, I'm not sure what you would do, because if you want to do something fancier, you'd have to have like PDB information, basically, because you'd need to know, like, okay, where in memory are things, and is this a float? Should I draw it as a float instead of a byte or something, right? But I honestly don't know what value you would get from that. Brian says, admittedly, I have not been watching all the streams or review of the code, but if this track's memory and the transient memory could reset itself throughout the frame, is what is tracked only what is left at the end of the frame? And if you have collected peak information, is it the reason the memory appears static because you're not doing anything new or different between frames? So, no. Let me just clarify something. We are tracking the memory usage just flat out, period. So the peak value is the value that was hit inside the frame. And that's why, for example, the frame temporary arena has a 46 megabyte peak, but only 3 megabytes is actually allocated, right? As for why it doesn't change, well, we wouldn't really expect it to change that much if the game is doing something fairly stable, because remember, we are a pretty reliable game in terms of memory usage. We don't do the thing that like most engines do, where just everyone allocates everything all the time everywhere and is completely lazy about it. So that's one reason why we're so stable. But there's another reason that we're stable, and that is that there are some things we're not tracking. And that is if an arena itself comes into existence and goes out of existence during a processing of a frame, we wouldn't see that. Right? And so there may be some arenas getting created and destroyed in the middle of a frame, and that we wouldn't track. So just keep that in mind. Are you planning to add more features to this? I don't think so, except maybe the scrolling. Started watching you a while back. Is the earlier episode still relevant, worth it, or should I start somewhere more up to date? Well, everything I do is programming that's involved in game development. So it depends what you're trying to learn. I would usually recommend that people watch, use the episode guide, right? Like go to handmadehero.org and click watch. If you go down here, there's like a previous episode thing, and look for stuff you want. Do you want to know about like scaling, or do you want to know about Fourier transform? Do you want to know about OpenGL? And then when you find something you want, like click on it, right? And watch it. That's why we have this episode guide. It's there to allow you to watch the things you want and not watch the things you don't want. But I wouldn't say that later things are better than earlier things in any particular way. It's more like whether the topic happens to interest you. Are you going to add an edit box to filter reduce the visible lines from memory? I don't know. Probably not. Let's see. Thanks for the image scaling explanation in the pre-stream. Could you explain about zoom towards the mouse position? Well, zooming towards the mouse position doesn't really have anything to do with image scaling. That's just saying that when you're going to display, anything, there's a transform that you're applying to it. And that transform moves and scales it. Whenever you apply a scale, the scale will always be about the origin of your coordinate system. When I multiply something by 3, it gets 3 times further from the origin, period. There is no other thing you can do. So if you want to scale an image and make it appear to scale about some other point, then what you're really talking about doing is, in addition to scaling the size of the image, which really doesn't mean anything about its location, you must also offset the location you're drawing the image such that it correctly centers it around some point you're trying to scale around. Right? So the way to think about it is to say, in addition to scaling the size of my image by 3, I need to take the location I'm drawing the image, take the mouse pointer, and say, well, wherever the image is relative to the mouse pointer, I need to scale that offset by 3 and add that to the location I'm drawing the image, right? Because that difference now needs to, move the transform the image by that amount, right? I'm not explaining this very well because it's kind of something we should really do on the whiteboard. But I think I explained this stuff when we were talking about transform centers before. So maybe something like this, we probably talked about this, just the concept that, you've got 2 things. You've got an offset that you're drawing things at, and you've got a scale, and those things are interrelated. When I change the scale, I need to change the offset to make sure that I now take the scaled thing and put it where it needs to be. So you're scaling 2 things, the size and the offset, right? And scaling the offset is going to have to account for where you want the thing to be centered. Another way to do it would be to say, write out the equation that says where a particular point on the bitmap is. When I started my frame, I want to know that before I started zooming, I want to know where the mouse pointer is. Well, the mouse pointer, right, is at the mouse pointer's location minus the offset that I'm drawing the bitmap at, right? That delta is how I get from the place I'm drawing the bitmap to the mouse cursor, right? So if I want the bitmap to now be drawn in the same location relative to the mouse cursor, after I scale it, I need to make the offset of the bitmap be my current mouse location plus the offset I was using from the previous frame, right? Divided by its scale and then multiplied by the new scale, right? Because I'm trying to build off of where it was before. So there's a lot of ways you could think about it. I feel like we've covered all this stuff before. If you really can't figure it out, we can do it sometime when I have more time. We could do a whiteboard session or blackboard session in our case where we show exactly what I'm talking about. But I feel like we covered transform centers several times in the past. The timing part of the profiler, you had it so you could click on a section and zoom into that section to see more details about a section. Do you see value for that here? Not really, and the reason is because with memory, it's usually not so important. It's pretty obvious what's going on most of the time, whereas with timing, sometimes it's not, right? So I guess what I would say is I got all the information I pretty much needed from the view we've got. You know, I mean, just that tells me pretty much everything I need to know. You know, I really don't know. I know what that is comprised of. It's not that complicated, right? And so I could see in a system that was sloppier about memory, needing more ways to like zoom in and gather stuff. But because we're pretty clean, you know, it seems pretty straightforward. I don't think we need to spend any more time visualizing that stuff. In the thread tutorial, you used a pointer to a function. I know that you want to keep it C style, but wasn't that cleaner to just use a method inside a struct? It'd remove every pointer equals func. So a couple of different things. One is that you'd have to define what you mean by cleaner, right? Because what does it mean for something to be quote-unquote cleaner? In this particular case, if we go look at the thing you're talking about, so you're talking about where we had, I don't know what we call that, work, I think. Yeah. So in here we had a thing where we said, look, we have a thing that we put a queue in here, and what we want to do is we want to say, there's a callback we use where we're going to say what we want to do, and then we have a thing where we have a pointer to some block of data that it's going to do that on, right? And so what you were saying is, why isn't it a method? And the question is, you know, is it cleaner? Without a definition of cleaner, obviously I can't answer the question, but what I can show you is why I just think stuff like that's a total waste of time. If you imagine, and I don't know, let me find some like place that I can use sort of as a scratch place to put this in here. If you imagine the two different ways to do it, here's the one that I did. And when you want to use this, you basically say, you know, whatever the function is, like queue work, something like this, or my work, right? I write one of these things, and then I say implement it here, right? When I want to add the work later, I say like add work to queue, and I say the my work pointer, and I say what the data is, right? And it adds one of these. So from the user's perspective, they do this, right? And from my perspective, that's exactly what I wanted to do. Now, if you did it the other way, you would end up doing this. The C++ way is to say, well, we've got a class, and that's really just another word for struct. There's no difference between those two things. And so there's the platform work queue entry. The platform work queue entry has this thing in it. And I guess, you know, I don't know, maybe there's a void star data in here or something like that, right, as well. So in here, we're going to say, well, we're just going to call this function on the thing, right? And this thing has to be virtual now, right? Because if it's not virtual, I can't change it to be something else. But I don't have to do this anymore, because when I call the function, it will get the this pointer. And so that, you know, doesn't have to happen. So that's fine. But, you know, off we go. And similarly, this probably has to have that in it or something, right? So it would look like this. I don't know how to get forcoder to not do that, but either way. So it's going to look something like this, right? And then when I want to actually do this thing here, now what I have to do is say, well, oh, and I should add the one thing that we have to do here is whatever this data is, I would have to cast, right? To be fair. So something like that, right? So here's the C++ way. I make one of these, and now I have to derive from that. So I'm going to say, like, all right, I've got the my data. That's going to be inherited from one of these things. It's going to have one of these in it, right? And then I'm going to have my int x down in here, right? And then I'm going to take this thing, and I'm going to implement it in here, and I do like that, and you know, maybe it looks something like this. Make sense? And so these are the two, I assume, if I'm representing correctly what you're asking. You're sort of asking, why didn't I do this version instead of doing this version? Oh, and then when I do add work to queue, I can't do this anymore, so what I have to do is instead something like this. Right? Make sense? So why prefer one of these to the other? And let me also put user's perspective in here. And you can kind of see the difference between the two. So here's my one, and here's the other one, right? And, you know, is there a good reason to prefer one or the other, et cetera, et cetera? Well, the first thing that you'll notice about these two is the function and the data have to be defined together, right? So let's suppose that the thing that I'm trying to do work on is already defined in my system somewhere. Somebody's using it, right? It's a real thing. Let's say, just for sake of an argument, that the thing is one of these. I want to do some processing on an HHA asset, right? So what would I do in both systems? In my system, you literally do this call. It changes not at all. Instead of my data, you just pass one of these. So I would just say HHA asset data, you know, the data, that's it. It just works. In fact, let me write that out separately so we can see. So in my version, I've got an HHA asset pointer, you know, existing asset. And here I do add work to queue, my work, existing asset. Done. I didn't have to do anything. If I come to the C++ version, it's like, okay, now how do I do this? Well, I can't go add a virtual function pointer to this thing because it's something that's stored in a file. Like, I can't add a virtual function table pointer to it. That'd be a complete disaster, right? So what I have to do to implement this thing that took one line of code for me to do in my version, I now have to do this ridiculous garbage. Make a new thing called mydata2 that also derives from public queue work entry. It also has to define this function thing again, like I do every time. And now I have to put the pointer in here. Then I can do add work to queue, right? Actually have to do this. Now that I think about it. So, you tell me, do you want to write these 2 lines of code? Actually, it's not even, that's the input to the function. So actually, do you want to write that line of code, or do you want to write that every time? Right? Now let's make it even more fun. I want to operate on this piece of data still, but I want to do something different. Well, in mine, it's another 1 line of code. I just pass a different function, right? Oh, but in the C++ version, not so much. I get to duplicate this entire set of things again and create my data 3 for having some other function here that does something different. Right? And in case you're wondering, this is why C++ code bases are like billions of lines of code and do nothing, right? Is because it's just a typing festival. Over and over and over and over and over and over and over again, right? And so then, for reasons I couldn't fathom, the way they try to attack these problems, rather than just recognizing that you just want to do this thing and you should just try and make it nice and concise to do that, are there a few improvements we could make, is they add like all these additional ridiculous things like lambdas and standard : garbage to try and make this, which just doesn't work, less onerous, right? And they'll be like, okay, well, maybe we templatize the work class on like what the function is, and then we wrap the function in a thing. And you're just like, it already worked. The thing before like already worked. Why are you adding all this stuff? And best case scenario, you end up in C++ 17 getting back to something that's almost this good, but usually not, and is like all this other standard library garbage with like all these templates getting expanded secretly, and you're just like, why did you do that? Why would you do that? You massively overcomplicated your language, your code, and the work the compiler has to do to produce something reasonable when you just had the answer to begin with. It's right there. So I just write the thing that actually does what the CPU does, and that usually is the best way. C++ is about arbitrary syntactic garbage that doesn't do anything, and then constantly trying to fight your way back to normal. Right? And it's just ridiculous. Don't go here and then try to wrap your way back to here. Just do this thing to begin with, and you're fine, right? I don't know. It's nuts. People just don't know how to program. Botner says, what about C++ lambdas in that case? Like I said, why? What do you need them for? Like, my version just works. You're just adding unnecessary language features that complicate the work the compiler has to do in order to get back to the same frickin' thing, which is just call a function pointer. That's all you needed. It's 1 line of code, right? And so like C++ is just, it's an orgy of features that the best case scenarios that get you back to the thing you just would have done in C, and usually they don't. Usually don't even get back there. When you actually go like look at what the compiler generated, it struggled so hard to produce something reasonable that like there's cruft in your code now. Because it couldn't quite figure out how to optimize everything out. That was all the C nonsense that C++ nonsense that they added in there, right? So off you go. let's see. I meant game memory dot platform add entry equals win32 add entry and game memory platform complete all work. Oh, well, that's because I keep a boundary so that anything that calls the platform layer calls through a pointer. That's just separation of the platform layer. It's just a preference. I like to keep that stuff separated that way. But you don't have to do that. I mean, if you don't want to. They don't change. So you could hard weld them in there. It makes it a lot easier to do stuff like switching things out under the hood, but you know. And it like the hot code reloading, that part needs to have those function pointers work. So you can't really make them member functions because it would call the wrong thing, right? But yeah, if you don't care about hot code reloading and you don't care about having the platform layer be and the game be swappable like that, then you don't need those pointers. My nephew started the computer science a year ago, and when I saw the educational materials, they are not good, and professors mostly teach toy examples. I think there is a problem with computer science education. Do you know how it can be improved? Maybe the production programmer should teach the programming courses. Yeah, I actually said what I thought was a problem yesterday. And really, it's just that programming is like a trade discipline, you know? And universities are not where you go to learn trades. You know, you wouldn't go to university to learn to be a blacksmith, I think is the example I gave. You study under a blacksmith. And the same is true of programming. You don't go to university to learn how to program. You study under programmers who actually know what they're doing. Unfortunately, that's not how we have produced our system. And it's true for a lot of things nowadays. Universities are like the worst place to learn how to do something, in my opinion, because they're mostly filled with people who don't know how to do things in production, right? They're filled with people who study things, and that's different. You know, the notion that you go to university to study literature makes sense to me. The notion that you go to university to learn how to be a writer makes no sense to me. It's never been that way and shouldn't be that way. University is for study, not for craft. But we've combined those two now, and it makes no sense because most professors in most disciplines aren't experts at crafting. So if you look at the world's best programmers, none of them are professors, I would say. So we've gotten ourselves into this really bad system where instead of computer science professors being people who study computer science and who publish things about computer science, and if you want to know how to do those sorts of activities, like sort of academic study, you go study under them. Instead, we have this weird notion that if you're going to be a production programmer, you go there. But why? Those are two different disciplines. You know, studying Turing's, construction of a machine, and is that the right way to think about computing, and is Church's thesis still, the correct way to talk about whether or not we can compute things? And those are important things to study, and they're abstract concepts that people need to be working on. But are the people who are most knowledgeable and most well-versed in thinking about those problems the people that you want to learn how to make a renderer? Absolutely not, right? They're totally separate disciplines that can inform each other, but that are not related in terms of what you do on a day-to-day basis, right? And so I don't know why we got ourselves in this situation, both in computing and everywhere else. It's a huge epidemic in the US. People going to university as something they have to do to get a job, but those 4 years could have been way better spent studying with someone in a practical setting, and they would have been way better at their job when they got out, right? And so we lost this notion that universities is for academics and that training is a different thing. How do you fix it? Good luck, right? That's a social engineering problem way outside of my area expertise and I can't help you, right? Let me take the last couple here. Would there also be an issue in C++ if you wanted to have it be in a queue and some other thing perhaps? Would you need to inherit from two or more things? It depends how you want to implement it. Usually, I think C++ programmers, if I had to like, put on their hat for a second, would not generally these days say inherit from two or more things. They would say put a pointer in one of them to point to the other thing, But yeah, you'd have to ask a C++ programmer. And these days, again, they'd give you some ridiculous answer with all kinds of weird, like, standard function wrapping lambda nonsense that, would just be yet another super complicated way to call a function pointer. Dave P00, is the C++ way a lot of hoop jumping just to avoid the cast from the void star to the data type that you need to do in the C function pointer method? Did the C++ committee reason that it's more type safe? The C++ committee doesn't really reason about things. I'm sure they had some pedantic nonsense that they think is a way you're supposed to think about things. And not wanting to cast a pointer may have been one of them. But, who knows? All right, I'm going to wrap it up. Okay. Thanks everyone for joining me through another step of the Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along the series at home, you always can pre-order the game on handmadehero.org, and it comes with a source code so you can follow along with it in the privacy of your very own editor. That's it for this week. I'll be back here next week when we may add scrolling to the memory window, or we may just be lazy and not do that right now and move on to the entity stuff that I wanted to work on. We'll see. That'll be my call. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.